It is noon straight up. Wednesday, time for another Lunch and Learn. And today we're thrilled to bring to you Kyle Palmer. He is from the mobile mapping solutions group at Leica. And so, Kyle, there's not a whole lot of fanfare here. We're just going to turn it right over to you and let you take over the room. So, folks, please welcome Kyle.
Great. Thank you for having me, everyone. Thanks for hosting me, KR. This is a great opportunity. I know that the Lunch and Learns are a good educational opportunity for everyone and to be exposed to new tools in the industry. And today I want to talk about one specific tool that I'm really proud of that Leica's introduced to our mobile mapping line of solutions. So there's a new software out called Cyclone Pegasus Office. And Cyclone Pegasus Office processes all the data from the mobile mapping sensors that Leica produces. The Pegasus TRK, our legacy sensors, the Pegasus P2 and P2U, and then the backpack. Today, we're just going to look at TRK data because it looks great. So, and I want to show it off. So we're going to skip over the general workflow. That's going to come up later. We'll talk about that later in a different in a video, but we'll talk right now about classification. So I'm gonna go to a small little project that might look familiar to everyone. It's just an overpass. It's a 4-lane overpass, and of mobile data. Looks really, really great, right? You got everything you need. Everybody's staying off the road. Everyone's staying safe. And I talk to a lot of people in conventions and just on the phone, and they go, "Well, this workflow is great and it's easy and it's helpful, but and I've seen a lot of tools. What's so special about yours? Why does it get me there faster?" Because the thing I hear a lot is extraction's the bottleneck, right? Well, this classification tool is really second to none. I'll show you why. To classify a point cloud, you get through the whole workflow, right? You load up your stuff, you get it on the right coordinate system, you do your QCs, you make sure everything's good. And then classifying is simply clicking this button. And it goes right to this fixed model. There's a series of layers here that you can see. And that list is growing and improving. So every release, we get a new model update. So it gets a little bit stronger, better layers, but very semantic, easy to understand. So we'll talk about now what that looks like. You end up with the result, something like this, right? So that looks great. Right, we're here at the, we'll look at it in 3D, and I'll switch these off. They're a little bit distracting. Those are the track lines and the where I drove, and then those are the these red balls are the image bubbles, just in case anybody was wondering. So we'll go here and look and go, wow, that did pretty good. So this right here is the road surface, right? And road surface, there we are. Road surface. So you can see it did an awesome job. It just pulled out the road surface right away. And I'll highlight the curbs. This is the curb one. I know this because of the color. And then this is a pedestrian, a man on a bike. So great job, right? Did an awesome job. But we can see there's a couple places where maybe it wasn't so perfect. It classified this barrier wall as a curb. I've just been working with this so much. I know these colors, but if I went and turned off curbstone, you could see some of those points disappear, right? Well, this is how easy it is to fix. We'll talk about fixing this real quick. So I want to go to let's see, wall. So it's on that. So it's all on that layer. So you can see there's a little bit of noise in there, right? Let's talk about fixing that. This is how easy that is. So you just click the area that you want to fix that's separated from the road surface. Just close it out. And it'll move everything into that layer wall. So now when I turn it off, when I turn off wall, you can see everything there is turned off from that wall. Now, I haven't done the whole wall just to illustrate how powerful that is, but that's how quick it is. I've just talked about now how easy it is to fix the classification and how easy it is to classify. And then I know what a lot of you might be thinking. You might be thinking, so what? right? Oh, it's great. It's all split up for me. Oh, what does that mean to me? Well, I'll give you a great example. So this is a project that I collected in downtown LA. What would it mean to you to be able to take and do a quick building analysis for a client? So we've got this road and we've got this stretch of road, and we want to see if all these buildings match up to the building line, right? Let's go look at it in orthometric, and we'll look at the classification. Now, look how powerful this classification is, right? So it's classified all of these buildings. Like I said, it's not perfect. It's it's an algorithm. So sometimes there's a bit of a mismatch. So it's classified this as wall and then also building. But for the most part, the building's pretty dead on. So I could do a couple fixes, or I could export walls and buildings. And I can pretty quickly port this over to something like Cyclone 3DR, or I could take it over through CloudWorks and CAD and just trace out these buildings, or I can automatically extract these buildings. I could just have every single building in this project classified. And the way that works is, I'll show you here. There's a setting and finalize. So one of the really powerful tools in this software is the exports. So you can export by a single track, which is this. I'll show you here. We'll close this. This would be a track. You can export that whole track as one point cloud. Or you can export by track multiple files. You can restrict the size of the file. Say that you're dealing with, you want a quick analysis and you want to restrict the point size of each file. And then you can export by track and classes, and you can also split by the scanner. So let's take a look at what that means. So in this case, this is a TRK 700. So what you can do is, this is a scanner and then this is a scanner. You can split by those scanners, and you can really fine tune what your deliverable is. And then you can split by class. So you can export out individual classes. All these is a separate layer. So what that might look like in the case of, let's see, so what that might look like here. So in the case of this, so in the case here of this downtown Los Angeles that I showed, I can just bring in every building and wall layer I wanted to, and just visualize those only. So we can take a look at that. VR desktop, we'll open a new instance of that. We'll see what that looks like. And I can perform an analysis on that. I can just pull in the road. I can pull in the, I can pull in poles and wires, and I can work on the things that I want to work on and restrict a lot of noise. So I'm saving myself some grief on the downline. So let's go here. Data. Neo. There we go. Export. So we'll take in the building, and we can see how quick this works. So we can take in buildings. So that's scanner one, building. That's scan one, scanner one, building, scan one, scanner two, building. I can pull in these layers. And let's look for the building here. All right, let's just do that. We'll pull those in very quickly. And you can see what a good job it did just pulling in the building faces. So if I had to do a quick analysis, or I only cared about this one feature, then I can quickly export these. I can quickly export these things and not bog down my resources on my computer, pulling in an entire point cloud, which, case in point, I have one here. So I have a runway that I worked on. That's a great example of this. So let's look at the runway. The project demo I did. Go look at this runway here. And this is about an 18,000 foot runway that I did 6 passes with full cameras and everything. And it's a lot of data. It's a ton of data. But with the classification tool, one of the things I can do is I can basically switch off all the noise and everything that I don't want. And pretty quickly get to analyzing. So I can turn off vegetation, everything here. And what that ends up looking like is, turn off the natural terrain. We'll turn off everything here. All these guys. And a couple more. What that ends up looking like is this. So this is optimized to handle LiDAR data. So let's say the algorithm kind of messed up like it did. It sort of classified some of this as pavement. Really quickly reclassify that. Natural terrain. Right? Done. That's how fast that is. Then I can just eventually export out, and I've left it this way on purpose so I can illustrate this in Cyclone 3DR. So I can pretty much just export out this layer. And what that looks like is something like this, right? Where I have this and I can really, really quickly do a mesh, a ground mesh on pavement only, and then extract a 30-foot grid of topo points. So this really, I'll show the mesh here. So let's talk about this. So just the runway, it looks like we've got about 480 million points. And then that noise constitutes about, 2 or so million points, right? That's what that would look like. And then you can take a look at the mesh. But you can do a mesh, and everybody knows and loves 3DR. You can do a mesh really, really fast. And we can just pull out the pavement on the runway. I think this is a really powerful tool. I think it has a lot of potential. I think you have the potential now with mobile mapping and this tool to go extract all the buildings, extract all the poles and wires. Or if you drove a job and we always talk about in LiDAR and talk about in reality capture, you capture all this extra data, right? So you have all these edge cases, and you capture so much so you don't have to return to the project. Well, this takes that to the next step. So, for example, if you were capturing all the poles and wires from a project along a roadway, and the customer suddenly said, well, we need to bring in some new equipment, right? And we need to make sure it'll fit. We need to make sure we have clearances. Well, you can say, well, yeah, let me shoot you over the runway. Let me shoot you over the high vegetation. Let me shoot you over any bridges or structures, just that layer, so you can do an analysis on that. This gets you there really, really quickly. Or you can pull out all the walls and fences on the side on a long linear project and do a quick right-of-way analysis and see if you have any encroachments. But that's it. It's a pretty quick tool. I'm proud of it. I think this is a great product, and I think it's very powerful. And I'd like to open the floor to any questions that anyone might have. If anybody wants to see anything or go into a little bit more depth about each element of the workflow that I've shown.
So Kyle, one of the questions that we had come up from our Facebook group is someone asked the question is, what is mobile mapping? And I realized, well, for those of us who work in the industry, that might be somewhat self-evident. That at the end of the day, I think folks that come from a background of static mapping, placing your scanner in one place and shooting for a period of time, might not be familiar with how mobile mapping works and what are some of the benefits and parameters of it.
Yeah, I'd be happy to answer that question, and it's a good question. I started this off with the assumption that that we'd all know, which maybe I should. Thanks for asking. I appreciate it. I work in it all the time, so I forget to look up every now and again and educate on that aspect. So mobile mapping is a process by which you put a sensor on a moving vehicle and collect LiDAR data and imagery at the same time. So there's multiple sensors. Let's take a look at this one. Let's take a look at our guy here. This is what the sensor looks like, and this is what the collection vehicle looks like. We'll just take a look at it in reality here. So this is our sensor. This is a TRK, and I'm in the tower cam. So right here, you have our main workhorse sensors. This is an Optec CL360 HD. And what it does is it spins in a circle. It just shoots LiDAR out in a circle, right? Both of these, and they're at a 30-degree offset. Okay. Underneath me, actually right here where we're looking, is a GNSS sensor. And then underneath that is an IMU. The GNSS sensor records the absolute position of where we're going, right? Of where we are at a periodic rate, right? And then the IMU records movement. It's maybe out of the scope of this how an IMU works, but basically it's a fiber optic kind of strand that moves around, and there's some sensors that show how it moves around. And then each one of these sensors resolves to this one, the GNSS, and then the IMU, they resolve to a line called the trajectory line. So we'll take a look at what that looks like. This would be the trajectory line, and it shows how you drove. So as we drive, it moves along. We'll go back to our sensor here, back to our sensor point of view. It moves these along because these don't spin like your traditional terrestrial scanner. They just spin in a circle. They don't move. They don't move around an axis and then spin around like having think an RTC 360, right? They don't do that. They're just stuck there. So as you move, that's what creates the point cloud. There's also two additional sensors in here. There's a SLAM sensor, which is short for simultaneous localization and mapping, and it uses a Kalman filter to use LiDAR to determine a trajectory. There's a sensor in the front, and then you can't see it on here, but there's a sensor in the back underneath the body of this thing. So a good way to look at this, let's turn off all of these, and we'll look at how this LiDAR looks. That's a great way to show how it looks. So you can see, let's turn off one scanner. We'll turn off scanner 2. So you can see it kind of moves along in a line, right? If you look at this, it's kind of like a line of data that comes off there. And then every little bump and dip is recorded by the IMU. So you can see there's like slight waves because this isn't a perfectly flat surface. The vehicle moves up and down. But all that gets smoothed out into this trajectory line, and then the LiDAR gets snapped to this line. So think about the analogy that I was told when I started was, think about a snake. This would be the backbone of the snake, and these LiDAR points would be the rib bones of the snake. And I think that's a pretty good analogy. I think that really works. Does that answer the question of what mobile LiDAR is?
I'm looking. Looks like it does.
Okay, good.
So we have another question. Boy, I'll tell you what, Kyle, you have got more questions than most of our lecturers. This is great.
Okay.
One of the questions is, with the classification tools being introduced into other Leica platforms, such as Reg 360, is the classification engine the same across all of them? Would you get the same results if you classified in 3DR versus the software that we're using here?
No, they're different models, but there's a way to send these layers over to 3DR so you can preserve them.
Excellent.
So if you took the raw point cloud here, If you didn't classify it, send it over to 3DR, you would get a different result.
Okay, and follow up to that from the same person. Are there any tools in the development pipeline that you could speak to that would help streamline the classification of points? Perhaps instead of having to draw a box using the fence tool, could you just select a plane similar to the region grow tools to help the software recognize that it should be part of the same classification?
Not that I know of yet. The next major release is coming soon. I believe it's coming in a couple months, and we'll see what comes out in there. And I expect this was a new tool, the reclassification, and I think it works great, in my opinion. But yeah, I would like to see more tools in there, and I'll write that down as a suggestion for our team, and maybe they're already working on it.
Yeah, that's something.
But as far as I know, nothing along the lines of planes, or at least not from what I've been told, are in the pipeline yet. So
from the product management side, that sounds like a really great feature.
It does. Yep. I'm writing it down. It's a good idea.
I've got it written down here too for you. Another question coming forward is how many classification items are in the library, and what is recommended to control the drive? Are control targets recommended, and how many controls per mile?
So it's about 20. So every time we get a release, this gets refined, and it kind of goes up and down. It's about 20. For example, on an earlier model, there was a viaduct, and that's been removed. So I expect more layers to come that are a little bit more useful. But yeah, it fluctuates. So I don't want to tell you, and then you go, well, they said there's this many layers. And the second question was, what was the second question?
Hang on. The second question was, what is recommended to control the drive? Are control targets recommended, and how many controls per mile?
It depends. So it depends on the accuracy and the requirements of the project. So if you're working for a DOT, they probably have a manual that you have to go by, and you want to put them every. So, for example, like a general rule of thumb is every 500 feet, and then you tie every 1,000 feet, and then you use the ones in between as checkpoints to check your data, check your solution, and keep those independent of the solution. Because what happens is it's like a nested registration. So you use the targets, and then it works it into the entire registration. So you want to leave some targets independent of that, so you can check and make sure that you have a good registration. And about every 500 feet. Now, that being said, this has RTK on it. So you can connect to networked RTK like SmartNet, and you can just drive a project. So like this massive, huge project where I've done 4 tracks on, a little over a 3-mile runway. Well, let's go to processing, right? It's a huge set of data, like hundreds of gigs because of all the images. But one of the really cool things about this is, say I'm okay with RTK. Let's take a look at this one. Actually, let's go look at this one's on a drive. I'll go on one that's a little bit faster. We'll go back to a good example. I love this one. It's a good one. So every project you collect, if you go for the RTK option, give me a moment here. As you're driving and you're connected to an RTK service, in this case, SmartNet, you get on the fly an RTK based trajectory. So as soon as you pull this off the drive that goes in the computer that is connected to the sensor, you have this trajectory. This comes over with the project, with everything. And if you click this and hit OK, blah, 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 you hit open, and then you hit process, you can just blast through this thing. Like you can get all this data out real quick. It's going to have a little bit more slop in it because it's an RTK only. It's an RTK only trajectory, but there might be a case where that's all you need. Maybe you just need to do a sign inventory. Maybe all you care about and all your customer cares about is these images, right? And the LiDAR is secondary. Maybe all you want to know is, an engineer just needs to see what this bridge looks like, for example, and go see if there's any spalling or cracking. Like, let's go forward here. Right? Maybe it's like there's spots, for example. That's all the engineer needs. There's a bunch of pictures. Well, shoot, you can get that out on an RTK. I can go run this project in 30 or so minutes and shoot this out on an RTK only trajectory and get them all the images in an LGS and TrueView, and they're off to the races in a day. So there's different levels of accuracy that you might want to tune to, and this gives you the flexibility to do that. So RTK only, PPK. PPK with multiple stations, your own base station, and then all the way up to incorporating control points on the ground. Hopefully that answers the question. I know it's a little bit long-winded, but
it was very, very informative, and I think you gave folks exactly what we try to achieve here at Lunch and Learn. We have time for one more question, and this will have to end our session today. But this question is, for those that are running the Pegasus Manager, what are the primary benefits of going to Pegasus Office?
It's a lot easier. We're not supposed to say easy here, but the workflow's cleaner. So the workflow's cleaner. Admittedly, there's a lot more stuff is not exposed to the user. So, but in a way that's good, because if you have a normal project and you've done all your field procedure, you know your stuff. This is nav prep. This used to be multiple button presses and multiple clicks. And, if you miss something in Pegasus Manager, you might have to go back and do it again. Well, this is, this button right here, nav prep, replaces a lot of button clicks, and it does most of the work for you. Processing SLAM is really easy. Most of it is just button click, because I'll be honest, like the time that I need to spend is not here. This is meant to get you all the way out to here as fast as possible. And that's the primary benefit, is you get your point cloud out as fast as possible, because this is a ton of data and there's a ton of features to extract. And most of these projects have a lot of work to go in with them on the downstream process. So that's what I'd say the benefit is. And there's full support. So whoever's asking that question, I can't see. If you've got a P2 or a P2U, please reach out to me. I'll walk you through this and show you how to use it, and you'll see right away. You'll want to start using it. It's really nice.
Well, Kyle, I think that was a pretty in-depth answer, as were all of your discussion points. Fantastic and outstanding job. We appreciate you having your first Lunch and Learn with us here at Kuker-Ranken, and we look forward to many more with you. That was an outstanding presentation.
Thank you. Thank you for having me and hosting me, and thank you everyone who tuned in to listen. I appreciate your time. I know you're all busy.
Well, then that's just it. We know folks are busy, and we're grateful for you to come and spend your lunch hour with us. And since we've been talking about mobile mapping, next week's Lunch and Learn on April 12th is with Brady Reich, and he's going to be going into mobile mapping using the BLK ARC mounted on the antibiotics animal. So that's next Wednesday at noon, mobile mapping with the BLK ARC on the animal. So you want to get signed up for that. And then following that, the next week on the 19th of April, we'll be with Jeremy Kippen going through the GS18i and understanding the different models. Excuse me, I said GS18i and I meant GS18. We'll be discussing all the different models and capabilities and options available for that product line. So we've certainly got our Leica lineup happening over the next few days, and mobile mapping will be supported for the next couple of weeks in terms of our Lunch and Learns. We look forward to having you there. So folks, thanks again for chiming in and tuning in with us to today's Lunch and Learn, and we'll see you next Wednesday at noon. Until then, be safe out there.